Today we're going to start looking at section 5.2. So we are going to use various methods in order to prove that lines are parallel. So every single time in the past, we've been given parallel lines and then using that information to set up equations or whatever the case is. Now we're going to try to prove parallel lines. So we're not given that. So we have something called converses. They're essentially us flipping these statements around from all the theorems that we've been talking about for these last 3 days. So this corresponding angles converse states that if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So notice that in this picture, I do not have parallel lines marked. Instead, I have angle 2 and angle 6 congruent. And those are corresponding because they're on the same side of the transversal, and one is interior and one is exterior. So because those two are congruent and they're corresponding, they follow this converse that I can then state that line M and line N are parallel. So essentially, our shortcut here would be us not starting with parallel lines because that's what we're proving. So I'm starting with the fact that corresponding angles are congruent. That is what is given to me in this picture. And so from there, I am then going to be able to say that I've got parallel lines. Okay, so because angle 2 is congruent to angle 6, then we know that line M is parallel to line N. Okay, here's another converse. We've got interior angles converse. If two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. So once again, I'm not starting with parallel lines. I'm starting with angles that are congruent. In the picture, 4 and 5 are inside those two lines. They're on opposite sides of the transversal. They are alternate interior angles. So because alternate interior angles are congruent, that is enough information to then give us parallel lines. So essentially, because angle 4 is congruent to angle 5, we know that line M is parallel to line N. But that's only because they're alternate interior angles and they fit this converse. We have exterior angles converse. So if two lines are cut by a transversal and alternate exterior angles are congruent, then the lines are parallel. So notice that angle 2 and angle 7 are alternate exterior angles. So that allows us to state that M and N are parallel. So once again, if alternate exterior angles are congruent, that is enough to give us parallel lines. So we're just flip-flopping all of our statements with this converse. We're proving parallel lines. It comes after the arrow. Okay, notice that we have same side interior angles converse. It says if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So notice that here are two interior angles. They're on the same side. If I add them together, they add up to 180, so that makes them supplementary. So that's why line P and Q are parallel. So here, if same side interior angles are supplementary, that gives us parallel lines. Here's our last converse, same side exterior angles. So if two lines are cut by a transversal and same side exterior angles are supplementary, then the lines are parallel. So once again, exterior angle, 80 plus 100 gets me 180. So that makes them supplementary. So if I have same side exterior angles that are supplementary, then I have parallel lines. All right, let's take a look at some examples. So the question is, are lines M and N parallel? If yes, we're going to state the theorem or the postulate that allows us to conclude this. If not, then we're done. So if I'm looking at A, I see that I have two congruent angles. So I want to know, well, what kind of angles are they? Are they going to relate to us then being able to conclude that we have parallel lines? Notice that these two angles, these are vertical angles. They share the same vertex and they're directly across from each other. That's why they're congruent. Notice that those vertical angles have nothing to do with line M. So yeah, those two angles are congruent, but in this, because vertical angles are congruent, that doesn't necessarily lead me to parallel lines. This one I cannot say. So we do not know if line M is parallel to N. So we're done. We can't state a theorem or a postulate because vertical angles will not allow me to conclude parallel lines. Okay, but if we look at part B, we've got an angle that is marked outside on the right, and we have an angle that is marked outside on the left. These are alternate exterior angles. And so because they are marked congruent, if we have alternate exterior angles that are congruent, remember that is enough to prove that we have parallel lines. So my answer to this is yes, line M is parallel to line N, and it's because of that reason that I just stated. If I take a look at this, the question asks, is the line AB and the line CD parallel? If yes, once again, we're going to state the reason why. So notice that the two angles that are given are measures that are inside of the lines we're trying to decide whether or not are parallel, and they are both interior. So same side interior angles, I want these to add up to 180. I want them to be supplementary. So let's check it out. If I add these two together, 48 plus 132, that is going to get me 180. So that tells me that these two angles are supplementary. So yes, that means that the line AB is parallel to the line CD. And our reason is because same side interior angles are supplementary. And that's what then led us to parallel lines. All right, let's take a look at an algebra problem. Notice that in this diagram, I have lines A and B, but I don't have them marked as parallel. The question is asking, are these parallel? So we have to figure out what X is, so then we can start figuring out measures of angles and seeing if we have a relationship of either congruent angles or supplementary angles that will allow us to conclude parallel lines. So when I'm looking at all of these expressions, you have to make sure that you can only set up an equation of something that you absolutely 100% know to be true. And the only thing that's in this picture that I absolutely 100% know are that these two angles down here are vertical. And so remember, vertical angles are congruent. So that's the information that I'm starting with in order to try to solve for X. So I can set those two expressions equal to each other, and we can go from there. So I'm going to subtract 2x from both sides. That gives me 3x minus 18 to equal 24. I'm going to add 18 to both sides. So now that gives me 3x to equal 42. And I'm going to then divide both sides by 3, and that's going to give me 14. but 14 is not my answer. That's not how I tell whether or not something is parallel. So now I have to look at the relationship of all the different angles. Something that I see are that this expression that we haven't used yet and this expression that we did use, those are same side interior angles. So if I can get those two to be supplementary, then we have enough information to back up that yes, A and B are parallel. But if I can't get those two angles to be supplementary, well, then we don't have parallel lines. So my question is, are these angles supplementary? So in order for us to figure that out, we're going to have to substitute 14 in for those x's. So our first angle, I'm going to call that angle 1, and then I'll call this angle 2. So the measure of angle 1, we're going to take 4 times 14, and then we'll add 8. So 4 times 14 is going to give us 56. When I add 8, that gives us a 64-degree angle. Then when I substitute 14 into that 5x minus 18, well, 5 times 14 is going to give us 70. And when I subtract 18, I get 52 degrees. So I'm going to add those two together, 64 plus 52, and that is only going to give us an 116-degree angle. So because that does not equal 180, I do not have supplementary angles. So A and B are not parallel. And this is because same side interior angles are not supplementary. Okay, in order for us to have parallel lines, those two angles, same side interior angles, have to be supplementary. All right. So let's talk about a couple of postulates. One of the postulates states, through a point not on a line, there is exactly one parallel line to the given line. So a picture to describe this situation. Say I have a point, I'm going to call it A. Say I have a line, I'm going to call it L. Okay, what it's saying is that I can draw a line through point A that will then be parallel to the line L. But there's only one way for me to do that. Okay, so through a point, not on a line, there's exactly one parallel line to the given line. So I can only draw that one way to make them never intersect. Then we have a theorem. It states if two lines are parallel to a third line, then they are parallel to each other. Essentially, it's kind of like the transitive property where we're linking different things together, but this time it's transitive property not of congruent pieces, but of parallel lines. So let me show you what I mean with a picture. So say we have line A and line B, and I am telling you that they're parallel. Okay, so line A is parallel to line B. Say then I have this third line, line C. I know that line B and line C are parallel. So B is parallel to C. If I have that information, notice that it looks like B is parallel to two different lines. So based off of that linkage there, that transitive property, therefore, I know that A is parallel to C. Okay, because if A is never going to intersect B, but B is never going to intersect C, then A and C are never going to intersect either. Okay, so we're going to use those two pieces of information to do something called crook problems. So we've got these two pictures here. It says if A is parallel to B. So I forgot to put the letters there, but line A and line B are parallel. So I can even mark it in my picture. So same thing here. A and B are these two lines, and they are parallel. All right. So if I want to find the measure of angle 1, we have a problem because the transversal is not going through both of those parallel lines. There is a crook to it, okay? There's a bend in that transversal. But the point that helps form that angle, I can draw a line that is parallel and that will become parallel to not only A, but also to B. So now I have 3 parallel lines. So we broke up angle 1 into 2 different angles. I don't know that the angles are congruent, but I've got 2 smaller angles. If I can figure out what those 2 smaller angles are, all I'd have to do is add them together, and I've got the measure of angle 1. So I'm going to start with line A, and now this new parallel line, and here's my transversal. Okay, so ignore the bottom half of the picture for a second. I know that I need to figure out this angle because it's part of angle 1. So it looks like with the 100-degree angle, I'm dealing with same side interior angles because those 2 angles are both inside of my parallel lines. Well, same side interior angles, when I have parallel lines, they're supplementary. So take away 100 from 180, I know that that angle has to be an 80-degree angle. All right. Now I want us to focus on the bottom 2 lines with this transversal. Okay, so now that I'm looking at the green, I see that I have a 40-degree angle and my other unknown angle, which is what I want, that's a part of angle 1. So I want to know what's the relationship between the 40-degree angle that's given and the angle that I'm trying to find. Well, they are both interior angles as well, and they're on opposite sides of the transversal. So these are alternate interior angles, and when I have parallel lines, alternate interior angles are congruent. So that has to be a 40-degree angle. So the measure of angle 1 is me then adding the 80 and the 40 degrees together, and that tells us that we have an 120-degree angle. Okay, exact same idea with part B. I don't have another parallel line, but through that point that is making that angle 1, I can draw a third parallel line where then I can have 2 different sets of parallel lines and a transversal. So if I start with the top 2 lines and its transversal, I see that the angle that I want is this angle right here. The angle that is given is on the opposite side of the transversal. These are alternate interior angles, and when we have parallel lines, alternate interior angles are congruent. So that had to be 75. Then I want to look at the bottom portion with its transversal. Once again, I want to figure out what this angle is. And given the information, that 35-degree angle is on the opposite side. So once again, I have another set of alternate interior angles. And with parallel lines, those are congruent. So now that I know that part of angle 1 is 75 and the other part is 35, I get to add those 2 pieces together to figure out what the measure of angle 1 is. So 75 plus 35, that is going to give us an 110-degree angle. All right, let's take a look at this. So this diagram should look familiar. We've been doing this for a while, but notice that this time I'm trying to figure out which 2 lines are parallel based off of the 2 angles that are given. So in this problem, I am given us angle 12 and angle 24. So these 2 angles right here. Notice that they are being formed by, they're being formed by this line. So this line, because it's touching both of those angles, that's the transversal. So A is the transversal. So that means what are the 2 lines that are helping form angle 12 and angle 24 that are not going to touch each other? And hopefully we notice that that would be X and Y. So those are going to be the 2 lines that are parallel. And then I'm asking, why do I know they're parallel? Well, based off of the information, notice that 12 and 24 are on the same side of the transversal. One is interior and one is exterior. So these are corresponding. Given the measurements, they are congruent. So when I have corresponding angles that are congruent, that is enough information to then give us parallel lines. All right, let's take a look at the next one. We are dealing with angle 16 and angle 17. Notice that those two angles are being formed by this line, by line Y. So that's our transversal. Notice that 16 is also made up of this line, which is B, and 17 is made up of this line, which is C. So notice that B and C are the two lines that are not going to ever touch. Those are going to be my parallel lines. So now I need to justify why I know that. So looking at the measures of the angles, these are not congruent, they are supplementary. Noticing that the two angles that are highlighted are in between the two lines I want to be parallel, so they are interior. They're both above line Y, so they're the same side. So when I have same side interior angles, they're not congruent. Notice 45 and 135, if I was to add them, they're going to add to 180. So I know that they're supplementary. And so because that's the case, that gives me my parallel lines. Okay, so that's us using a various amount of methods to prove that lines are parallel.